This is the video recording of us running you through our model-to-model employee schedules for Mediterra and Princeton. Uh, First things first, you have to download OpenSolver and make sure that that's all set up.
Okay, so to download OpenSolver, you first want to open Google Chrome, which is opened right here. You want to type in OpenSolver in your search bar and click on the first link that pops up. Right after that, you can click on OpenSolver 2.8.6. Once you click on that, the file is gonna download for you. Over there, you see that's the file. So after that, you can go to your downloads folder and fire up OpenSolver. Click on solvers, Win64, CBC, and click extract all. Once you get that, you want to click Control C and copy the link that's given there and click extract. Okay, once you've extracted that file, you want to open your model, which is the model over here, and go to File, Options, Add-ins, Excel add-in, Go. We want to browse for that extracted file right now, and if you click in this search bar over here, you can paste the link you just copied, click enter. After that, you want to click on the OpenSolver file and click OK, and click OK again. That is over here for you. So now, once you have OpenSolver installed, you want to customize your ribbon and open the developer tab in in your Excel file. Go to developer, go to Visual Basic. Because we have a function that makes OpenSolver run, you just want to add it in from your tools and go to Tools, References, and have OpenSolver entered over there. So just click OK and close this tab. So now once you have this downloaded, now we can basically get into how our model runs.
So we're going to start off here on the the manager's inputs on the employee database. And the manager needs to input the names of all their employees, as well as the experience that each employee has, a maximum and minimum hours per week that each employee should work, and that employee's salary per hour. Once the manager's done that, they can go to the main scheduling page, which you can see here, and they need to go through to enter first the number of customers that they assume each employee can handle in 1 hour, and the baseline number of employees that are needed to manage the restaurant even if no customers are there. Once they have those assumptions, they can input customer data. They can input customer data for the previous 2 weeks. And this data is necessary so that we can build the forecasting model and predict the number of customers coming in the future. You input on this sheet, you input the current day of the week, and you can click on the date on our month view calendar here. Let's just plug in Thursday, for example. And then you fill in the number of employees and the number of customers working at a given time. And we'll just fill in some random numbers here. We don't need to fill in the whole thing. We've already compiled some of the data for you. Once you've got all the data in that you're going to compile, you can just click on this Compile Data button here. We'll go ahead and click that. And this takes you first to a pivot table. Don't bother refreshing. That shows the number of customers coming in each day of the week at each time of the day. So we can see here we've got a peak around noon and 1 p.m. and then a larger peak around dinner time, which makes sense for this restaurant. This data you can see here feeds into the restaurant data tab, which we've already filled in. Once you have that data, you can go back to your shift scheduling page, and the employees will fill in their own availabilities on the employee scheduling. Every Sunday, the employees will fill in their availability. And here they check off, or here they plug in their name, and then they check off every day that they are available, every day and time that they are available out of all these options for the week. So we'll just plug in a few here.
While we're doing this, only employee names that are there in the database will be allowed to input their names inside this schedule given. Otherwise, it's going to return an error saying that the employee is not available in the database and cannot fill in a schedule. So that's the name you're going to put over here. We're just going to put that in right after we select some available times. We also believe that most employees should be available more than 50 hours a week at least, because if that's their full-time job, they want to be available to do it. For example, we had an employee called Sarah in our database. So once we would click that, we just have to click it and click compile. So that basically takes us to our optimization table where we've compiled this data.
Once the data has been compiled, you can see here Sarah's times for availability are marked in as 1s and 0s, and then summed up for each day. This information is also copied over onto our solver table, which you can see here. Again, their availability in the bottom. And then we use Excel's Open Solver capability to generate an employee schedule here.
However, before that has happened, we want to explain to you what's going on as well. So in the Solver tab, once all this data is inputted, we have a prediction of the employees that are going to be required every week, every day of the week at every hour, and that's going to be used to generate your employee schedule according to our needs, which takes us back to our main page to generate the employee schedule.
So once you have all that information inputted originally, you can go ahead and click the Generate Employee Schedule button. And this runs the model and generates a table of names along each day and time, along with a column totaling the number of hours that person is expected to work that day. So you can see here, Sarah is going to be working on Tuesday. She'll be working from 12 to 2, then at 4 p.m., and then 5 to 7. If you only want to see one day out of your entire week of work schedule, you can go ahead and click the Daily Summary button, input whatever day you'd like to see, in this case, Thursday, and generate the daily summary. And that shows you just one day, just to simplify it a little bit more for your convenience. So that's our model. That shows that this will help employees schedule and predict their schedules in advance. You can generate this model and forecast it out a week in advance or more if you need to.
That's it. Thank you.
And that's it. Thank you for watching.
In addition to whatever we just told you, the objective function for our model for Metadata was basically to reduce and minimize the cost for budgeting the employees for the week. And that cost is pretty much seen in this solver table and on this solver sheet right here at the bottom in this area. This is basically the value for the week, if you want. And this value is further looked into with a risk model that we ran. And for this risk model, what we did was there is a function called @risk that is available on your computer, and you just have to initialize that function of yours. Click OK when that happens. Close. So now your @risk function is available to you in your ribbon. So what you want to do is in your solver table, in your sheet of @risk over here, we have put the hours worked by every employee, and we've run a triangular distribution to this, which shows the minimum hours, the maximum hours, and the most likely number of hours. The most likely number of hours is decided based on the experience that the employee has. So what we did was we put employees with the most experience would have the lowest number of most likely hours worked, and vice versa for the ones with the least amount of experience, as we would normally give people with less experience more work time and throw a lot of the easy work onto them. So that's what we've done here. And then the total cost is basically our output, if you can see, which is the total cost times the salary. Yeah. So once we do that, we basically go and run 1,000 or 2,000 or how many other iterations you want to run off your model to get an approximate value. You put the value in there and click Start Simulation. What that runs this graph for you, the simulation, and basically provides you with this value. This value is the mean value that you're expected to pay for the week for your budget. Also, you have a minimum and maximum value. That means your budget would not go below $3,528 and would not go over $4,285 in a 90% confidence interval. If it does, the chances of moving in either of those two directions is a 5% chance. And those are just another two features of your model that we thought would be really helpful for you to use for your future scheduling shifts. Thank you for watching.